Today we're going to study multiplication of rational expressions. Let us see this principle about multiplication of rational expressions. If P, Q, R, and S are polynomials where Q is not equal to 0 and S is not equal to 0, then if we have the fraction P over Q times R over S, this is equal to the product of PR in the numerator over the product of QS in the denominator. How do we multiply rational expressions? We are going to have these three steps. Step 1, factor each numerator and denominator completely. Step 2, multiply the numerators and denominators. Step 3, simplify by cancelling out common factors. Let us see example 1. Let us multiply the rational expressions. The first one is the 3x all over the trinomial x squared minus 6x minus 16 times another, the numerator is x squared minus 4 all over the denominator 6x squared. In step 1, we are going to factor each numerator and denominator completely. The 3x, we can show that this is 3 times x. The trinomial x squared minus 6x minus 16 is now factored out into x plus 2 times x minus 8. And then the second rational expression, in the numerator, the x squared minus 4 is now factored into x plus 2 times x minus 2. In the denominator, the 6x squared is now written as 2 times 3 times x times x. In step 2, we will multiply the numerators and denominators. So it is like we're going to combine all numerators as 1 and also all denominators as 1. So it will be like this. The 3 times x times the x plus 2 times x minus 2 in the numerator. In the denominator is the x plus 2 times x minus 8 times 2 times 3 times x times x. And then step 3, we're going to simplify by cancelling out common factors. The 3 times x here, we can cancel out with this 3 times x here. The x plus 2, there is a counterpart of x plus 2 in the denominator, so we can cancel those terms. You see here, the 3 times x is cancelled with this, and the x plus 2 is also cancelled in both the numerator and in the denominator. And then we will just copy the remaining factors. In the numerator, the x minus 2 will come down here. In the denominator, the number 2 is here, followed by the x and the binomial x minus 8. So this is our final answer. Let us have example 2. Let us multiply the rational expressions. Our first rational expression, in the numerator, n squared minus 5n all over the n squared minus 25 times the second rational expression. The numerator is n squared plus 10n plus 25 all over 5n squared. So I wrote all the three steps here at one time. So I'm going to do the step 1 to factor each numerator and denominator completely. The n squared minus 5n is now factored out into n times the binomial n minus 5. The denominator n squared minus 25 is now the product of n plus 5 and the n minus 5. The numerator n squared plus 10n plus 25 is now factored out into n plus 5 times n plus 5. While this 5n squared, it's now factored out completely into 5 times n times n. Actually, we can skip the step 2. We can go directly to step 3 by cancelling out common factors. This n here, we can cancel with 1n here. And the n minus 5, there is also n minus 5 in the denominator, while the n plus 5 here can be cancelled with the n plus 5 in the denominator here. So you see, the respective factors are now cancelled. And then we will just collect the remaining factors. In the numerator, only the n plus 5 remains. In the denominator, we write the 5, also this n. So this n plus 5 over 5n is our final answer. Let us have example 3. Let us multiply these rational expressions. Our first rational expression, the numerator is 3a squared minus 8a minus 3 all over a squared minus 25. The second rational expression, in the numerator, it is a squared plus 10a plus 25 all over 3a squared minus 14a minus 5. So I wrote the steps on this side, and I will now go to step 1 to factor each numerator and denominator completely. In the numerator, in our first rational expression, the 3a squared minus 8a minus 3, the factors are 3a plus 1 and the binomial a minus 3. If you are not familiar with the factors, you can review our video about factoring of trinomial of the form ax squared plus bx plus c. So in the denominator, the a squared minus 25, the factors are a plus 5 and a minus 5. And then times the second rational expression, the a squared minus 10a plus 25 is now factored into a minus 5 times a minus 5. The denominator, 3a squared minus 14a minus 5, the factors are 3a plus 1 and a minus 5. Also, we can skip the step 2. We can go directly to step 3, and that is to simplify by cancelling out common factors. Look at this 3a plus 1. We can cancel this with the 3a plus 1 in the denominator of the second rational expression. The a minus 5 can be cancelled with the a minus 5 here. There is another a minus 5 where we can cancel this with the a minus 5 down here. So you see now the respective factors are now cancelled out. And then we will just collect the remaining factors. So in here is the a minus 3. We copy down here. We can remove the grouping symbol. And in the denominator, the remaining factor is the a plus 5 only. So we will just copy that. Also, we can remove the grouping symbol. The next question is, can we cancel this a and a in the denominator? The answer is here. There is a note that we cannot remove a term from a sum. So the a in the numerator is part of the sum a plus a negative 3. In the same way, the a in the denominator is part of the sum of a plus 5. So this a minus 3 over a plus 5 is our final answer. Example 4. Multiply 5x squared y raised to 4 all over 12x y cubed times 6x squared all over 20y squared. Note that numerators and denominators are monomials. Let's do cancellation first on the coefficients. These 5 and 20 we can cancel out. 5 becomes 1 while 20 becomes 4. This 6 and 12 we can also cancel out. 6 becomes 1 while 12 becomes 2. Then we multiply the coefficients. 1 times 1 and 2 times 4. What about the variables? We're going to apply the laws of exponent. Going back to the coefficients, we have 1 over 8 times, let's see the variable x. We have here x squared, another x squared, and in the denominator, there is a variable x here. So we can write x raised to 2 plus 2, then minus 1. What about the y variable? There is y raised to 4. There is y cubed in the denominator, another y squared in the denominator. So we write y raised to 4, then minus 3, then minus 2. Let us now simplify the exponents. So we copy the 1 over 8, and for the x, it becomes power 3. For the y variable, we have negative 1 power. And for the y variable, we have negative 1 power. So let's combine 1 over 8, this x cubed, and the y raised to negative 1. We rationalize this negative exponent, so finally, the final answer is x cubed over 8y. Example 5. Multiply 2n squared minus 3n minus 14 all over 25 minus n squared times n squared minus 10n plus 25 all over 2n squared minus 13n plus 21. Let us factor out numerators and denominators completely. We can see that we have trinomials in the numerator here, another trinomial here, and another trinomial here. I'm going to put the link about factoring of trinomials in the description of this video. And we have here the difference of two perfect squares. So, the factors are, for this numerator, 2n minus 7 times n plus 2. For this denominator, factors are 5 minus n times 5 plus n. For this trinomial, factors are n minus 5 with power 2. The factors for this denominator, 2n minus 7 times n minus 3. Then we simplify by cancellation. 2n minus 7 and 2n minus 7, we cancel it out. There is no other common factor. But we have here the square of n minus 5, and we have this 5 minus n. We can do something to this 5 minus n, and we simplify this into the negative of n minus 5. We are doing this to show that it becomes a common factor with the n minus 5 here. So we can cancel this along with the n minus 5 in this numerator. So for the exponent, we simply here exponent 1 from 2. So finally, we collect the remaining factors. This is negative, so we copy it here. And in the numerator, we have n plus 2 times n minus 5. All over, the 5 plus n, we can write as n plus 5 times the n minus 3. This is the final answer.